Hi there, I'm Bill Gerald. I'm the Chief Energy Engineer for CalPortland. Today I'm coming to you from Tucson, Arizona at the Orange Grove Ready Mix plant. We're going to do a tour today of the Ready Mix plant here, and we're going to focus on some of the energy attributes of the plant, where the energy focus is, and what are some of the items that we do to minimize our energy footprint. You know, all this tour is part of the Energy Star industrial focus meetings that are happening this year, and hopefully you enjoy this presentation. Well, here it is. It's a ready mix plant. We have behind me is the one of the Orange Grove ready mix plants here in Tucson, Arizona. We have a truck unloading cement, Portland cement. There's a hose at the bottom going up a pipe. These tall silos have the Portland cement in it. Just to the left of those silos, you can see a kind of rectangular structure up there. That is the mixing area where the aggregates are brought in from, you know, outside, you know, piles, and the loader fills a hopper, feeds a conveyor that feeds that bin. Just below it, there's a rectangular structure that's vertical. That's a dust collector that's running when the ready mix truck is underneath the chute, and the charge belt that is feeding the material into the truck, it will run to ventilate the area to prevent dust from emitting from that operation. And then behind me is a horizontal tank for storage of bulk product. That's it. It's a ready mix plant, and we'll be talking about a lot of these things here. So here we are in Tucson, Arizona at the Orange Grove Ready Mix plant. They have 2 batch plants in operation right now. Both plants are currently running, supplying customers in the Tucson region. So a ready mix plant is a mixing plant. We're going to mix water, aggregates, which is going to be crushed rock and sand, and Portland cement. Those 3 together mix, and as they blend, they're going to start a chemical process that eventually it's going to harden into the concrete that we know. A standard typical time is 90 minutes to get to wherever your load is going to. So they have a 90-minute range. So that's why you're going to see ready mix plants kind of spotted around different territories, because they have a limited time range to get there. Well, here behind me are 2 air compressors. High pressure air is used in almost all industrial applications. Ready mix plants are no different. Used in operating cylinders to open gates, dust collectors, for emission control, a variety of pumping of additives into the system. So compressed air is an important utility. We use it, but we want to use it most efficiently. There's a 7-to-1 ratio, 7 horsepower of electrical work going into the system. We only actually get 1 horsepower of compressed air work out of it. So that's a very inefficient operation, but that's how compressed air works, just the physics of it all. The compressed air system is highly focused, and every plant we want to monitor air pressure, minimize air pressure where we can, and use it appropriately and efficiently. I always said compressors multiply. We probably had 1 compressor here at one point, now we have 2. So part of the making concrete is water. We need water to mix in with the aggregates, sand, rock, and also the Portland cement. That water mixture is an important part of the chemistry, and maybe not as well known is the temperature of the water is very critical. So in colder climates or in the winter time, we need to heat this water. This processed water needs to be heated up using some sort of a fuel, maybe natural gas, sometimes even diesel fuel. not as common as electric immersion heaters. In the summer times, in warmer climates like in the west, southwest, our Nevada, California, Arizona operations, we need to chill the water. We need to cool it down. You know, one of the methods is using a chilling system, basically an air conditioning unit that's chilling the water as it goes through, and as that water is chilled, it's brought up into storage tanks. We want to make sure they're insulated storage tanks so that we can save that water that we've spent a lot of energy to cool off. I focus on these chilled water units and these heating units because they are energy consumption. Obviously, we want to minimize that consumption. All right, so what we have one here behind me is a dust collector. On the ground level behind this red block is the motor and the fan. That fan is pulling air through the system, and you can see there's a downcomer stack that's actually coming down. You're sucking air through a baghouse. Baghouse is essentially a vacuum cleaner. We're drawing air through it, pulling it through filter bags, collecting the product, and then emitting from the shorter stack clean air. So, you know, environmental compliance, and it requires that we have dust collectors and bag houses to make sure that we are not emitting dust or our product out into the atmosphere. It's very important that these are operating. You'll notice that this is actually not running right now. It's not running because there's not a truck backed up loading. Some plants, and I think this was one of them, what we actually automated a few years ago, is changing that fan operation so that it only runs when necessary. This doesn't need to be running, pulling air through the load chute all the time. It only needs to be running when the truck is there dispensing the product. So we put in a very simple pair of wires that helps on the interlock starting and stopping the baghouse fan, and now it only runs when necessary. This was actually thousands of dollars in savings, and we did it in half a dozen plants here in Arizona, and it's just a sensible automation project that can be overlooked, but very easily rectified. Electrician comes in, pair of wires in the motor starter cabinet, and you're done. It was a great project, low cost, with a lot of payback for the system. So here we have the aggregate piles next to the ready mix plant, different sizes. A loader, front end bucket loader, will be picking up these different sizes and feeding them into hoppers. These hoppers have belt conveyors. Those belt conveyors are taking those aggregates of different sizes up to the batch plant. That batch plant is going to segregate those different sizes, and then when the control system requires it, pull the proper size of rock into the batch process. You know, for energy purposes, you want to have automation on these belts. Make sure they're only running when needed. An older plant, and some of these plants, the belts would run continuously all day long, and that way it was convenient because the belt was running, but obviously unnecessary and not very energy efficient. So automation allows for the belts to only run when necessary. All right, so here I am. I'm in the brains of the operation here. This is the batch operator shack. It's where he's controlling both the plants and supplying the concrete to the trucks, delivering it. You know, each batch requires a certain recipe that is used for whatever the job site's calling and whatever the job's calling. A really important position and an important aspect of energy management. Automation kind of coming right from here. the system is controlled from this location, and it's important to, for quality control, making sure that the product is delivered properly. And then from our aspect, it's important for energy management to be a part of the program, so that we're doing this as efficiently as possible. Well, here it is, the end of the road. Washing out the truck, getting the last bit of concrete out of it, and heading back to the plant, lining up for the next load. Hope you enjoyed today's video, seeing how CalPortland employs energy efficiency at their ready mix plant operations. And hope you've enjoyed the Energy Star Industrial Focus meetings, and have a good day. Bill Gerald, Chief Energy Engineer, CalPortland.